Oke, bismillah. Assalamualaikum warahmatullahi wabarakatuh. First of all, let's pray and thanks to our God, Allah Subhanahu wa Ta'ala, who has given us some mercy and blessings so we can attend and gather in this place in good condition, in happy situation. Secondly, my faith and salutation always be given to our Prophet Muhammad Sallallahu Alaihi Wasallam, who has gone up from the darkness and to brightness, from Jahiliyyah era to the Islamiyah era. So, hello viewers! Welcome back to Idea and We Can Take Talk series. Before we start, how are you guys? Okay, I hope you are always in good condition and happy situation. So before we start, let me introduce myself first. Hello everyone, my name is Vandana Kesha and everyone is Kesha and I am from 11 RPL and I am the host for this sweetie tea. Yay! Okay, today in Weekend Tech Talk series, we are going to talk about understanding the concept of object-oriented programming, or OOP. As we know, OOP is one of the most important programming concepts that every developer should understand, especially for us as RPL students. And of course, today we have a special speaker who will explain this topic clearly and interestingly. She is Azwa Melantika from 11 RPL. And before will come to Azwa Khalisa, we're gonna tell you what we are gonna do in this weekend tech talk. At the first of all, there is opening and we introduce ourselves and then we're gonna move to the Q&A session. We're excited to introduce for the speaker and then we call it Azwa Khalisa.
Okay, hello everyone.
Hi Azwa.
Hi Keisha.
Hi Azwa, how do you feel today?
Oh my god, this afternoon I feel so good.
Oh,
Alhamdulillah.
all right, Azwa. Before we continue to the next material, can you introduce yourself first?
Alright, so hello everyone. My name is Azwa Melantika and people usually call me Azwa. And I'm right now at the 11th grade majoring at RPL. Nice to meet you
Okay,
guys.
nice to meet you too, Azwa. Okay, Azwa. I think everyone is already and excited. You can start the presentation now. Good luck and enjoy.
Okay, thank you Keisha. Wait a
Okay.
second guys. Is my screen already shared guys?
Yes.
Alright. Okay, so good afternoon, everyone. And right now, I'm so excited to see you all here today for today's Weekend Tech Talk. And today, we're going to dive into a topic that is basically the secret sauce of a modern software development. If you are ever wondered how big games or apps like Instagram or Mobile Legends are built without the code running into a giant mess, the answer is right there for understanding the concept of OOP. So just slide it. Okay, so let's start with the big questions. What is OOP, guys? OOP is object oriented programming, isn't just a fancy way to type a code. It's a programming paradigm. This think of a paradigm as a mindset or a way of look at a problem. Instead of just writing a long list of instructions for the computer to follow from top to bottom, we focus on objects as the primary elements. We try we treat our code like it's made of real-world things that have their own data and their own actions. It makes our code cleaner, more organized, and way easier to fix when something goes wrong. And to master OOP, you first need to understand the relationship between a class and an object. Imagine you want to build a house. You don't just start stacking bricks randomly, right? You need a blueprint. In OOP, the blueprint is the class. It contains the definitions, the attributes like color or size, and the behaviors like open the door and turn on the lights. Now, once you see the blueprints that actually build a house, you have an object. You can use one blueprint to build 10 different houses. They all have the same structure, but one might be blue or the other might be yellow. So, one blueprint can make many houses or objects. So, for the next, there is the OOP's concepts, or we can call it for the four pillars. Pillars. Sorry. Now let's look at the four pillars in here that make OOP so powerful. Think of this as the ground rules. For the first, there is encapsulation. This is about hiding the internal workings. Like a folder that keeps your file safe, encapsulation hides the complex data and only lets you interact with it through a simple interface. You don't need to see the gears to use the machine. For the second, there is inheritance. This allows us to create a new class based on an existing one. If I have a class called vehicle, I can make a car class that inherits all the features of a vehicle without me having to type the code all over again. For the third, there is abstraction. This is for hiding implementation details. When you use a remote control, you only care about the buttons, right? Not the electronic channels inside. Abstraction lets us focus on what the object does instead of how it does it. The last or the fourth is polymorphism. This means many forms. It allows different classes to be treated as the same parent type. For example, if I give the command speak, the dog or a cat, for example, will bark and the object of the cat will meow. And it's same the command but different results. So after we know it, the theory, let's cook it up. I'm going to show you how this actually looks in real code editor. We're going to build a very simple system so you can see these classes and objects in action. Okay, wait a second, guys. Wait a second, guys. I want to prepare for the Visual Studio Code first. Wait a second. Is my screen already shared, guys? Not yet.
Haven't what?
Oh, really? Already?
Already.
Okay. So let's get up to create the file for the class and object first. So here, type as a class and object dot in here. And after that, we make a class. Here, for the example, the name is painting. Here, and then we type string and then the painting title. The next, we type the string again, and we put the painter name in here. Enter it again and put it integer in here and type year created. Okay, and then in here we type it for the constructor in here, painting this painting title, and this for the painter name, and the last one is this for the year created. Okay, we already done to make the class. Right now we want to make the method. In here we put void, we put display on the wall. Sorry guys. And then we put it print in here for print the output. The painting title. We put the painting title in here. Is now displayed on the wall. Okay, have done. We already make the method for the class. And right now we want to make the output. In here, void main. Oops, sorry. We put var in here for the variable. We make the first painting. This is the name of the variable. And don't forget to put it in here, the big P. And next, we put our class in here, and there is the argument or the parameter that we must to fill. Just delete it and put based on the class. For the example, the painting title, I want to fill it with, for example, Everest Mount. Here, put the painter name, for example, is me, Azwa, and next for the year created, we put it 2026. All right then. Oh, sorry, because it's integer, so no need to put this one. Yeah, okay. Next, we want to make the method and the painting and the class painting. So we put here the first painting, the variable, and the method display on the wall. Okay, sorry guys. There's an error in here. Okay, Just want to try for running it, even if it's error, guys. Put Dart in here and class and object. Dart. Oh yeah, there's an error in here. The name is expect this before this. Okay. Do we need to remove it? Oh no. Hmm. How do we to solve it? Teaches. Okay. Let's retry to running it again. And yeah, ta-da! The output is the painting tiled Everest Mount is now displayed on the wall. So that's the output of the class and object. And next, we want to make for the abstraction one. Okay, for in here, I want to put the class, abstract, class, and for the example, I want to put vehicle in here. And then put it void. Turn on the engine. Okay, after that we make class again at the 5 line. We put car in here and extends vehicle. Then we put void, turn on the engine, and we put the print for printing the output. The car engine is running. Room. Okay, and then put in there. And below this, we put the void and the main again. We put variable. I want to make a car, so I put the car variable in here and put it, oops, sorry, car here. And then behind this, we put the car variable and the method. Turn on the engine. Okay, sorry, forgot to put here. Nah. Okay, let's rerunning it in the terminal. Dart abstraction dot. Oops, sorry, it's typo in here. Yep, the car engine is running. Boom, this is the example of the abstraction type. So for the next, we continue to make the inheritance dart in here, and we make the class again. For example, I want to put animal in here, and then we put void and it for the method. We print I can eat. And then for the next, for the class of the cat. For example, extends animal. We put the class animal there, and we put foot meow meowing. This is for the cat's method, and we print I can meow. And don't forget to put the semicolon here. And for the next, for the other animal, let's we say we want to make chicken. Extends animal foot crowing. This for the animal's behavior, and we print it for put the output in here. I can crow. Put the semicolon in here, and then at the end, like before, it's still same. We put void and main in here, and we put the variable of the cat. Here we put the class, and then we put the cat and the behavior one. The cat variable and its behavior. It's meowing. And then below we put the cat and the other behavior. It's eat. And then for the chicken, I want to make the variable is, for example, Rembo. And then put the class of the chicken in here. And at same as the cat, we put the variable Rembo and its behavior. It's crowing. Then done. This is the code example of the inheritance. Don't forget to save it and running at the terminal. Dart inheritance dot. Okay, this is the output of the inheritance, guys. In here, there's I can meow, I can eat, I can crow. So the terminal shows the output of the inheritance that shows the behavior of the cat and the chicken one. Okay, for the next, we make the encapsulation one. Encapsulation dart. And in here, I make the class again because OP cannot show the output if we didn't use class and the object one. So in here, for example, I want to put robot in here and put the string. Here, robot name and the string as well. Oh yeah, I forgot to say that we put underscore behind the yeah, beside the R in here in front of the variable. It's make the variable is private. So if you want to make a private variable, you can put underscore in front of the variable, guys. Next, we put we put the void in here and set robot name because we want to put the name of the robot. Put string and the new robot name, and then we put the private variable in here, the robot name, and the new robot name. Okay, enter for this yellow. Put string in here and get the robot name, and then we put return for returning the robot name. Okay, just ignore it for the error. In here, we put the void and introducing itself. It's for the robot's behavior. Here we put the print and we put the output. Hi, my name is, put the variable of the robot name, the private one, and then just Control X and we put in here inside of the class one. Okay. All right. And then for the next, we put the void and the main again. Put variable in here. And we put the new robot. And we put the robot class in here. And then we put the new robot dot set the robot name. Okay, this is the parameter that you must to fill it. It's obligate to put the new robot name. So for example, I want to put the name is Gemini. And then we put the new robot that introducing itself for calling the behaviors of the robot. And then this is the example of the encapsulation code. And start to running it at the terminal. Encapsulation. Yep, the output is hi, my name is Gemini. So this is the example of the encapsulation method. For the next, don't forget to make the example of the polymorphism one. Here we make the class again. And for the example, I make animal in here. Sorry. And the behavior is voiced. Wait. Here I put the print animals make sounds with tones. Make sounds with tones. And then below of the code we put it the class of the animal. For example, is cat again. Extends for the animal. Void and it's voice. We can print for the output of the behavior is meow. Here we make the class again for the another animal, for example, is cow. And in here we put void, voiced, and put in here. We print moo for the cow's fowl, for the cow voiced. And next is for the void and the main. We put variable of the animal. In here we make a new variable and it's equal to the animal class. And then variable of the cat equals to the cat. And make the variable of the cow equals to the cow one. And then put the animal class in here. Dot for the behavior is voiced. Put the cat voiced and the cow voice. Okay? Try to running it at the terminal. Polymorphism. Tutor. Yeah. You can see the for the output in here. Animals make sounds with tones. Meow and moo. Alright, so we already tried to make all of the examples of the OOP code. There is abstraction, inheritance, encapsulation, and the polymorphism. And don't forget for the most important one is the class and object, guys. So, wait a second. Okay, so and that's the wraps of our quick dive into the world of OOP. So I hope this helps you realize that coding doesn't have to be a confusing mess of lines, but it can be as organized as a set of folders or a well-drawn blueprint. So thank you so much for your attention, guys. Okay, we'll stop this cursor.
Okay, thank you Azwa for the insightful and well explained presentation about object-oriented programming. Now we would like to open the Q&A session.
All right.
Okay, hello Azwa. So now I want to ask something. So why do we need a constructor when creating an object? Can a task run without a constructor defined manually? So that's all for my questions. Thank you.
All right, thank you for your question, Chalil. So I will try to answer Chalil's question. So for me, in my opinion, we need a constructor primarily for initialization. Think of it as the setup phase of an object. So we have 3 points for the constructor in here. It's for assigning initial values and memory allocation. And the last is triggering essential logic. So that's for the answer of your question, Jalil.
Okay, thank you, Azwa. And the next is Hi, Azwa.
Hi, Ira.
So yes, I have a question for you. It might be a basic question, but I'm really curious about this. Do you enjoy coding or do you not? If yes, why? And if no, why? Thank you.
Okay. Thank you for your question, Ira. For okay, so I will try to answer Ira's question. So actually, I'm enjoying for the coding things. Um, at the JHS, I didn't have any basic knowledge about coding, and yep, I just know and learning coding at this features. So at the first, I'm really curious and really burnt out, guys. For at the 10th graders at the first semester, I'm really burnt out for making the code, and I cannot solving if my code is there's an error in there. And then when I'm trying to improve myself at the second semester when 10th grade, and Alhamdulillah, at since at the 10th grade when that second semester, I'm enjoying code until right now. So yeah, I'm enjoying coding even though at the first I'm really struggling with it at the first. Okay, thank you, Ira, for your question.
Okay, Azwa, thank you for the answer. So, thank you for Azwa to the answer the question, and maybe you can leave the live.
Okay, thank you, Keisha. Bye bye.
Bye. Okay, we have come to the end of today's session. Thank you for our speaker and thank you for everyone who participated. Have a good day and see you the next time. We have today's discussion have been helpful and meaningful for all of us. Have a great day, stay motivated, and see you at our next session. I'm Fanda Nakesha. Telah saya say, wassalamualaikum warahmatullahi wabarakatuh. Bye everyone.